What's up, guys? It's Mr. Bringle, and today we're going to be talking about waves and wave speed math. So we're going to start by talking about the variables that are included here in the equation that we're going to use, and we'll go from there. Okay. So the first thing that we're going to talk about here is that we already know velocity, right? V for velocity, and that's meters per second. But this is specifically going to be wave velocity or wave speed. Okay. And then the next one is a new one. It's a funny little symbol. This little symbol here, this is the Greek letter lambda. It's kind of like an upside down Y, if you will. You kind of draw it like this with a little curve. And this is wavelength, okay? And wavelength, it has the word in it, length. You would measure length in meters, and wavelength is measured in meters. So this is more or less your distance value, okay? One wavelength is the distance between crests or troughs on a wave. We'll learn more about that later. But it is the distance between one wave to another. So this is a length or a distance. I'm going to put distance here. So if you guys remember, with our previous equation, we have for speed, we have V is equal to D over T, right? So wave speed, because it's measured in meters per second, is distance in meters divided by time in seconds. Well, that brings us to our next variable here, which is frequency, which is a lowercase f, and it does need to be lowercase because capital F is force. And this is measured in hertz, Hz. And 1 hertz, so Hz, 1 hertz is equal to 1. Actually, hold on. Let me erase the 1 here. So a hertz is equal to 1 over a second. 1 over a second is a hertz. So this is going to be your time value here. Okay, so it's a measurement of time. Now, the equation looks a little bit different. So when we actually go to do our equation here, wave speed is equal to wavelength times frequency. Okay, wavelength times frequency. And let's kind of think about that, right? We've got speed is equal to wavelength times frequency. Now let's write the units out for that. So that would be meters over a second is equal to a meter times, I'm going to rewrite this as 1 over a second. So you can actually see here that that would be a meter over a second, right? Because meter times 1 on the top here is a meter divided by a second. So you can see that actually works out so that our units are meters per second, the way that they should be. Okay, so there's our equation, and obviously we can rearrange this equation. We can solve for, I'll rewrite these out here. So if we wanted to solve for wavelength, that would be wave speed divided by frequency. And if we wanted to solve for frequency, that would be wave speed divided by wavelength. Okay, so we have all those versions of the equation. Let's look at some example problems here. So the first example problem, it says one end of a rope is vibrated to produce a wave with a wavelength of 0.25 meters. The frequency of the wave is 3 hertz. What is the speed of the wave? Okay, so let's write out our givens here. We know that the wavelength is 0.25 meters. Okay, we know that the frequency is 3 hertz. Okay, and then we are going to be solving for the wave speed. And that's going to be in meters per second. I actually want this up here too. Okay. So for our equation here, we'll go ahead and I'll write the equation out over here. Wave speed is equal to wavelength times the frequency of the wave. Our substitute step here, wave speed is equal to, 0.25 meters times 3 hertz. Okay. So for our final, I'll go ahead and put this down here in this little box here since we've already got a box. Move my face a little bit. And that is going to be a wave speed of 0.75 meters per second. It's terrible S there. Okay. All right. So there's our first problem there. And we will go ahead and move on to number 2 here. Okay. Number 2, what is the wavelength? So that I already told us what we're solving for, of a wave that has a speed of 3.5 meters per second and a frequency of 2 hertz. So for our G step, we have the speed here, which is 3.5 meters per second. We have the frequency, which is 2 hertz. And we are solving for wavelength. Okay, so again, we're solving for wavelength. That is going to be measured in meters because it is a length measurement. Our equation for this wavelength is equal to wave speed divided by frequency. So that's going to be 3.5 meters per second divided by 2 hertz. And then our final step here, go ahead and plug this into the calculator. 3.5 divided by 2. It's going to be 1.75. So wavelength is equal to 1.75 meters. Okay. All right, so there are a couple example problems for wave speed math. You will have some practice problems that I would like for you to do on your own, and that should be on the very next page. So it should be, if we look at it here are your practice problems. You will do these on your own, and then we'll give the answers in class. If you have any questions, make sure to let me know.